Good morning, students. I am Munsi Rashidul Islam, Assistant Professor of Department of Mechanical Engineering, JIS College of Engineering. Now, not today, we can start a new topic, and that topic is design of spark gear. We have know about the spark different types of gear that actually used in industry purpose, but the design of each and every spark gear that is very necessary to the different types of application in different mode. So gear is actually a positive drive. That drive is actually that can transmit or that can transfer power or torque from one shaft to another shaft, uh, and that is actually is gear that is most important part of any mechanical component, and that mechanical component is very usual in each and every field you can see. So the simplest form of gear is known as spar gear. It is actually straight and parallel teeth. So in straight and parallel teeth, the teeth formation will be uh, uh, very easy designing of teeth formation. That is actually very important to design the parts of the spar gear. So that is actually the case of spar gear that you can use to designing each and every part of the component of material. Now, what are the uses of gear, or what are the benefits of the gear? So why we can use spar gear rather than the any other types of gear? So in spark gear, in gear drives that can actually used for a uniform motion without any slip. So without any slip, it can be transmit motion without any slip. That means no slipping chance will be there. Next, high input speed that also be available in spark gear designing purposes. Next, variable output speeds. Variable output speeds that also very important. And if your output speed is variable from time to time, so it can be affected to the designing of any spark gear. And next is high precision, compactness, and interchangeability, and with higher level of accuracy of mechanical efficiency. Now, next, what are gears? So that is actually what are gears. So gears are means of changing the ratio, changing the rate of rotation of the machinery shaft. That means any machinery shaft, that is actually the rate of ratio or rate of rotation can be controlled by the gears. They can also change the direction of the axis of rotation. They can obviously change the axis of rotation and can change the rotary motion to the linear motion. So gears not only transfer or motion or torque from the same direction. It can also happen either in linear motion to rotary motion or rotary motion to linear motion. That also be possible in gear. Now next is mechanical engineers sometimes say always from the use of the gear and rely on the advent of the electronic controls and availability of the tooth belts. Since the robust gear of the high speed and any other type of gear that you can use for the designing purpose. So spar gear also a easy and cheap available gear. Its design is very simple, or it can also be a high in economical and also with cheap rate. That also be a one advantage of spar gear. Now gears and gearing. Gears are used to transmit torque or power positively from one shaft to another shaft by means of successively engaging teeth. That is actually gear. So if you see that one gear, that means spar gear or any type of gear, you cannot mention properly with the proper definition. You obviously told that the gear drive is a perfect answer for any type of gear definition, because it is actually a positive drive, and that positive drive obviously transfer motion from one shaft to another shaft with the help of in any medium. Next, gears also may be used to increase or decrease the speed of the driven shaft, thus decreasing or increasing the torque of the driven member. Now, next point is shaft in a gear drive. Shafts in a gear drive or train are generally parallel. That means in spar gear, the shafts with driven or the train, that is actually parallel, and they may however be driven at any angle up by means of the suitable design gears. Suitable design gears means we can change the design of any type of gear, and that may be spar gear, helical gear, or any type of gear. You can obviously change the rotation of the gear. That is actually uh, that is actually the case of designing the spar gear. And now next is they are used to place in the belt and rather forms of friction drives on exact speed rotations and power transmission must be maintained. Must be maintained. Now, types of gear. Types of gear. Number one, spar gear. That is actually generally used to transmit power between two parallel shafts to which they are attached. That is actually spar gear. Next, internal gear, and that gears are used where the shafts are parallel and center must be closer together than could be achieved within a spar or helical gearing. Next is helical gear, may be used to connect parallel shaft or shaft which are at an angle, and that angle may be known as the helix angle. Herringbone gear, on most installation where it is necessary to overcome in end thrust, such gear are used for the purpose of transmitting motion. And next point is Bevel gear. When two shafts are located at an angle with at an angle which their axial lines intersecting at 90 degree, the power is generally transmitted. The power is generally transmitted by means of bevel gear. The power is generally transmitted by means of bevel gears. Next, meter gears. When the shafts are at right angle and the gears are the same size, when the shafts are in right angle and the gears are the same size, they are called meter gear. Angular bevel gear. Angular bevel gear, if the axis of the shafts intersect at an angle apart from 90 degree, the gears are known as angular bevel gear. The gears are known as angular bevel gear. And next one is hypoid gears. Hypoid gear, that means modified bevel gears having helical teeth are known as hypoid gears, and hypoid gears are used in automobile drives. Automobile drives it also be used. Next, worm and worm gear. When shafts are in right angle, shafts are in right angle with a considerable reduction in speed. That means it is required when ohm gear and ohm gears are used. And last one is rack and pinion. So rack and pinion, when it is necessary to convert rotary motion into linear motion, and this may be used. It is actually used for the purpose of converting motion from rotary to linear or linear to rotary. This is this is a figure. That figure is actually a spark gear figure, and um, that figure is parallel teeth with straight and parallel teeth. That is actually example of spark gear. And next, that is a helical gear. Helical gear. So both that also clear that this type of gearing system, the um, position of the teeth is parallel to each other but creates some angle. That angle is known as helix angle. Herring, that is actually the figure of herringbone gear. Next, gear terminology. Gear terminology. First is addendum. So addendum is the radial distance between the pitch and pitch circle and the outside diameter of the height of the tooth above the pitch circle. So addendum is actually the radial distance, and that is center to center, a pitch to pitch circle. That is actually the pitch and the circle to the outside diameter or height of the tooth above the pitch circle. That is actually known as addendum. Next, center distance. Center distance is known as when the two gears are in connected or when the two gears are in matching conditions. Then the center to center distance between the two gears, that distance is known as center distance. Next caudal addendum. Caudal addendum means is the radial distance measured from the top of the measured from the it is the distance from the top of the tooth where the caudal thickness and the pitch circle intersect with each of the teeth of the tooth. Caudal thickness. It is actually the thickness of the tooth measured at the pitch circle. Circular pitch. Distance from a point on one tooth to a corresponding point on the next tooth. Circular pitch. Circular pitch. It is actually from a point, distance from a point to one tooth to a corresponding point on the next tooth. Next is circular thickness. Is the thickness of the tooth measured on the pitch cycle, and it is also measured on the arc thickness. Clearance. Clearance, it is actually the radial distance between the top of one tooth and the bottom of the mating tooth space. It is actually the distance at top of one tooth to the bottom of the mating tooth space. That is known as clearance. Dedendum. Dedendum, the radial distance from the pitch circle to the bottom of the tooth space. Radial distance from the pitch circle to the bottom of the tooth space, that is known as dedendum. Next, diametral pitch. Diametral pitch. It is the ratio of number of teeth for each inch. It is the ratio of number of teeth uh, for each inch of the pitch circle diameter of the gear. Next is working depth. It is actually the distance that a gear tooth it is actually the distance that a gear tooth extends into the tooth and a space of a mating gear which is equal to the addendum which is equal to the addendum. Now next point is involute. What is involute? Involute, that means involute, that is actually the curve that is produced by a point of stretch sting when it is unwrapped from a given cylinder. That is known as involute type shape teeth profile. Basically, two types of teeth profile we can see. One is circular teeth profile, cycloidal teeth profile, another is involute teeth profile. But most of the cases, we can use involute teeth profile, and this is very popular, and this type of teeth profile is mostly used in industry purpose as well as or any gear design processes. Next is linear pitch. It is actually the distance of from a point on one tooth to a corresponding point on the next tooth of a gear rack. So, module linear pitch, it is the distance from a one point on one tooth to a corresponding point on the next tooth of the gear rack. That is called linear pitch. Next module. It is the ratio of pitch circle dia to the number of teeth of the gear. Pitch circle dia to the number of teeth of the gear, that is called as a module. Outside diameter. It is also known as the overall diameter of the gear, and which is pitch circle plus the two addendums. It is pitch circle plus two addendums. That is also a point that can be considered as a total diameter of the gear. So that is called as outside diameter. Next, pitch circle diameter. It is the circle which has the radius of half of the pitch diameter with its center to the axis of the gear. That is known as the pitch circle diameter. Now, next is pitch circumference. It is the circumference of the pitch circle, and it is actually the total periphery of the gear that you can easily calculate for the designing of the gears. Next, pitch diameter. It is actually the diameter of the pitch circle. It is actually the diameter of the pitch circle, which is equal to the outside diameter, which is equal to the outside diameter minus two addendums, minus two addendums. Pressure angle. It is the angle formed by the line. It is the angle formed by the line through a point of contact, through a point of contact of mating teeth and tangent to the two base circles and line of right angles to the center of the gears. Root circle. Root circle. It is also known as the circle formed by the bottom of the tooth space. Next is root diameter. Now, root diameter is actually the diameter of the root circles, and tooth thickness is actually the thickness of the tooth, and that is measured from the pitch circle. Now, next point is hole depth. Hole depth, that is actually the full depth of the tooth and distance equal to the addendum minus addendum plus the addendum. This is the figure, and that figure you can see the actual all points. That points I already explained in the previous slides. So that is actually the pictorial view to show up the all points of spar gear or any type of gear. Now you can see that cycloidal gear, helical gear, bevel gear, home gear, rack and pinion, all the gears are mainly based on the basic fundamental. That basic fundamental is actually for the transmission of torque or power or motion can be transmitted when the two gears are in contact position or are in meshing position. Now let us see. We can see a next point, that is actually rack and pinion. Next, rules and formulas for spar gear. Number one, formula multiple addendum. Addendum A is equal to Cp into 0.3183. Cp means circular pitch into 0.3183. Now diametral pitch is equal to 1 by dp. Now next, and center distance cd is equal to n plus n into cp circular pitch whole by 6.2832. Diametral pitch, that means divided the total number of teeth in both gears by twice of the diametral pitch. So that means cd is equal to n plus n, capital N plus small n, by 2 into dp. dp means diametral pitch. And next, pitch diameter addendum and dedendum. So ca that means the cordial addendum, that means 1 minus cos 90 by n into p. Next, cordial thickness short form is ct, and that is actually sine 90 by n into pd. And next is cordial pitch. That means center to center distance, and multiply center to center distance by 6.2832 and divided the product by total number of teeth of the tooth gear, and that is actually Cp is equal to Cd into 6.2832 by n plus n. That is actually the formula of spar gear. Now, lot of formulas are there. You have to see the all formula. Uh, Now, circular pitch, clearance, diametral pitch, number of teeth, all the points. And if you know if you have some idea on the gear terminology, you can easily put the basic equation or basic formula in the main designing conditions, and you can get the result in one by one. So these are the points you have to be considered and for the design of spar gear, and that is the actually basic. Now next is gear cutting. Most gears cut on milling machines are generally used to repair or replace a gear that has been broken or lost or is no longer carried in inventory. In industrial purpose, mass production of gear, special machinery that is used. The most common type of gear generating machine are called as gear hopping machine, and it is more economical to buy a gear for a gear manufacturing company. Gear mainly two types of methods are used to production for mass production. That is, one is gear hopping and another is gear honing. So gear hopping is the best suitable process, and that process you can use for future perspective. It is more economical to buy a gear for a gear manufacturing company that to produce gear on a machine in order to carry for the faster production and save the time. That is actually the gear cutting of any spark gear. That is actually spark gear is the simplest form. So that is actually the case of designing the spark gear. So that's all for the today's lesson. Now we can discuss in the next class with new topic. Thank you.